Chapter. Yes, Judah? Coach Smith's YouTube channel. But all you have to do is just like for today, if you put 3.4 CCA Math 6th hour, it'll come up. Actually, you can just put CCA Math 6th hour in the YouTube search bar, and you'll find all of them. You don't have to actually go to my specific channel, but that's Coach Smith's channel is what it's called. Coach Smith Math, I think. All right. Now, what we're talking about is factors. Okay? So let's remind ourselves. The factors of 8 would be what? Johanna? Do what? Okay, give me all of them. All right, we know we got 1 and 8. And we got what? 2 and 4? Is that what you said? Okay. Are there any others besides 1, 2, 4, and 8? No, there's not. Okay. Now, let's look at the factors of 24. Somebody give me the factors of 24. Quade. 6 times. I want all of them. All right. What's the others? Brittany. What? 3 times 8. What's the others? Johanna. All right, 2 times 12. Are there any others? I think that's all of them, isn't it? All right. Now, as we look, the two numbers have a 1 in common. They have a 2 in common. They have a 4 in common. And they have an 8 in common. So the greatest one that they have in common would be what? Johanna? 8. Yep. 1 through 28. So the GCF is 8. Okay? Because that's the greatest common factor. Now, obviously, that was fairly easy because I'm dealing with two numbers that are easy to list the factors for. Okay? The problem we're going to have is that they're not always going to be that way. Okay? So the first way that you can find the GCF is to list all of the factors of the numbers you are comparing. Okay, that's the first way. All right, now, as I stated, I can show you right here in 7th grade math, first hour this morning, those were the first two numbers. Whoops, actually, no, those were way below that. First two numbers we had were 24 and 63. Did this morning. Okay? We listed them out. Pretty simple. Those were not actual two problems. Those weren't actually two of the numbers they had in their homework. Our second set of numbers was 198 and 216. Okay? So we have to know another way because it would be very, very time-consuming to list all of the factors of 198 and then list all the factors of 216 and then compare them. So there's got to be a shortcut, and there is a shortcut. Okay? The second way, for example, if I had these two numbers, 84 and 120. Now, right there you can tell that would take a lot of time to list all the factors of those two numbers. Okay? So there's got to be an easier way or a shortcut. The easier way or the shortcut is this. The second way to find the GCF is to prime factor the numbers you are comparing. Okay? So, this gets into what we've already talked about. I don't care if you use inverted division or whether you use the factor tree. It makes me no, never mind. I don't care. Okay? It's whatever's easiest for you. All right? Now, so if I take 84, and as I said the other day, I'm always going to do it inverted division because that's just the way I think. Okay? Now, for you, if you use the factor tree, then right now when I'm doing the inverted division, you do your factor tree. Okay? You don't have to copy down inverted division if you're not going to do it that way. Okay? Do it the factor tree if that's the way you want to do it. Personally, the numbers that we're going to be dealing with today, a lot of them are very large. So you may struggle a little bit of finding, factors and all that you can use your factor tree. All right? Now, 84. We start with our first prime number, which is 2. 2 goes into 84 because it's even. It goes 42 times. 2 goes into 42. 2 goes into 4 twice. 2 goes into 2 once. 2 doesn't go into 21, but my next prime number does, which is 3. 3 goes into 21 7 times. So my prime factorization is 2 times 2 times 3 times 7. I am listing it out for a specific reason. Okay? So when you're dealing with GCF, you don't really want to put it in the 2 to the second times 3 times 7 with exponents. Okay? Now I got a prime factor 120. 2, 60, 2, 30, 2, 15. 2 doesn't go into 15, but 3 does. 3 goes into it 5 times. So obviously, I'm the teacher, so I can do that real fast, but as you can see, that inverted division sort of moves quicker sometimes. Now, I'll show you here in a second. Once I get done with the whole thing, I'll show you the other way, just for this one problem. All right, now, so my prime factorization of 120 was 2 times 2 times 2 times 3 times 5. Here's what I do. I take and I circle the numbers that are common. Okay? And then I'm going to bring one of those numbers down. And then I'm going to take and multiply 2 times 2, which is 4. 4 times 3, which is 12. So my GCF, and this is how they will put it, of 84 and 120 is equal to 12. Okay? Now, like I said, all we're trying to get to is this point right here. Okay, so whether you use the factor tree to get that prime factorization or whether you use inverted division, doesn't matter. Okay? Please remember that when we're talking about prime factorization, prime factorization, all of your numbers must be prime. Okay? So I can't have 2 times 4 times 6. Those aren't, 4 and 6 are not prime. Okay? In other words, look, I'll write you an example. 2 times 4 times 6. This isn't prime factorization because 4 and 6 are not prime. Okay? That is not prime factorization because the 4 and the 6 are not prime. Okay, I've told you all that and told you all that and told you all that, but some of you are still doing it because of your grades that I saw, on your worksheet that most of you did not go home and do anything with this weekend. Because most of you got the grade of, what I saw on there on Friday when I was walking around the room trying to help you. Okay, so that's prime factorization. Okay, now another little note here. The GCF will never be greater than the smallest number that you are comparing. Okay? So, like in our first example, we did 8 and 24, and we found the GCF was what? On the first problem I did, what was the GCF? Brittany? 8. Okay? Is that greater than the two numbers that we were comparing? We were comparing 8 and 24. Is 8 greater than 8? No. 8 is equal to 8. Okay? So your GCF of 8 and 24 can't be 9, can't be 10, can't be 12, can't be 16. Why? Why can it GCF not be any of those numbers I just listed? Brittany, what do you think? Right, but why? Why would that statement be true? Nick?
Because it's bigger than the number.
Yeah, but why? Explain to me why. Can you divide 10 into 8 evenly? No. Can you multiply 10 times some other number and get 8? No, not unless it's a decimal or a fraction. Okay? So it can't be a factor if it's larger than that number. In other words, what I'm saying, see, I don't think you understand what I'm saying. If I'm going to list the factors of 8, can I have 12 as a factor? No. 12 times nothing equals 8. Okay? So, no. 12 cannot be a factor. So 12 cannot be the greatest common factor of 8 and 24. Okay? So if you do, for example, here's what a lot of kids do. Been doing this for a long time, and here's what they'll do. They'll see this right here. They'll see this little group of numbers right here. Okay. For some reason, it just does not want to circle those numbers. It'll erase them, but it ain't going to circle. You'll see this little group of numbers right there, and what you'll do is this. You'll go 2 times 2 times 2 times 2 times 3 times 3. You'll do that right there, and it ain't there. It is. It'll show up. You'll do that right there, and you'll multiply that out and come up with a huge number like, 224. And then you'll tell me the greatest common factor is 224. And I'll go, no. Well, I did it just like you did. No, you didn't. You didn't do it just like I did. How many 2's do I have in that? In my greatest common factor right here, how many 2's do I have? 2. Okay? Not 4, but 2. You only take one of the common pair. Okay? All right, let's look at another problem. I'll do this one with the factor tree. For those of you that use the factor tree. 48 and 60. And like I said, you can use the factor tree and the inverted division. Okay? 48. 4 times 12. 60. 5 times 12. 4 is not prime, so 2 times 2. Those two are prime. 12 is not prime, 3 times 4. 3 is prime. 4 is not prime, so 2 times 2. I only circle the numbers that are prime on my factor tree. Okay, so my prime factorization is 2 times 2. I got to check them off because I want to make sure I get all of them. Times 2 times 2 times 3. Now, back over to 60. 5 is prime, so I can circle it. 12 is 4 times 3. I can circle the 3. 4 is 2 times 2. I can circle the 2. So the prime factorization of that number is 2 times 2 times 3 times 5. Okay? Now, I'm going to circle the ones that are common. That 2, and that 3. So, that is 2 times this 2 times that 3. So that's 4 times 3, which is 12. So the GCF of 48 and 60 equals 12. See, the two methods are the same. Let me show you the inverted division. You don't have to copy this down. Be 2, 24, 2, 12, 2, 6, 2, 3. And then 60, be 2, 30, 2, 15, 3, 5. Okay, I still came up with the same prime factorization. There's that one, and there's that one. Okay? Inverted division and factor tree are just two different ways to come up with the same prime factorization. The reason I like inverted division, because you can even do this. With inverted division, I can just come right here and circle that and that, that and that, there and there. And then I just say 2 times 2 times 3. 2 times 2 is 4, times 3 is 12. Okay, that's the reason, one of the main reasons I like inverted division, because it's just right there for you. Circle the ones that are common, multiply them out. Okay, now, here's what happens. A lot of these have 12 as their their greatest common factor. Here's what happens when you have three numbers: 12, 18, 42. Okay, when you have three numbers, you still prime factor them. So, I got to prime factor all three of those. 2 goes into 12 6 times. 2 goes into 6 3 times. Two goes into 18 9 times. 3 goes into 9 3 times. 2 goes into 42 21 times. 3 goes into 21 7 times. So there's a 2, there's a 2, and there's a 2. They have to be common. The prime factor has to be common with all three numbers. Okay? So, there's a 3, there's a 3, and there's a 3. So I'm going to take this 2 times that 3. And you get what? 6. Now, if you were listing the prime factorizations out, it would be 2 times 2 times 3. That's 12. And then you had 18 was 2 times 3 times 3. Then you had 42 as 2 times 3 times 7. Same thing. There's your 2's. And there is your 3. Bring it down. Bring it down. Okay? This gets a little harder to see all of them when you line them up if you have 3 numbers. Okay, I want you to do this one on your own. And 50. I want you to find the greatest common factor between 40 and 50. Use prime factorization. Turn that back on. Prime factorization of 40 was 2 times 2 times 2 times 5. Prime factorization of 50 is 2 times 5 times 5. Now, if we circle those common prime factors, you get this right here. So then I bring down the 2, and I bring down the 5. 2 times 5, which is 10. Okay? We don't go, once again, we don't do 2 times 2 times 5 times 5. Here's what would happen if you did that. 2 times 2 is 4. Times 5 times 5. 4 times 5 is 20 times 5. That's 100. Well, last time I checked, 100 won't go into 40 or 50. Okay? So that would be wrong. That's the wrong way. Okay, you're going down a one-way street and you're going the wrong way. All right? All right. So, this group over here, you get on the board here. Trinity's group, get on the board over there. One's in the middle. Cameron, give Sophia that board underneath your chair. Huh? I'll put them on my desk. All right. You're going to find the GCF of 300 and 144 by prime factoring.